Hi, morning guys. Today we'll be looking at the solution for the tutorial chapter 2 physics 140. Okay, we look at the June 2018, yeah. Question 1. Question 1 asks about state the difference between scalar and vector quantities. Well, we know that physical quantity have two types. The first one, we look at scalar. Okay, so scalar has only magnitude. All right, that is number one. And then number two, for vector, okay, vector has magnitude and direction. That is the difference. That's the difference between scalar and vector. The only difference that separate them is the direction. Okay, so that is question number one. Okay, now number two, we have two vectors A and B. Okay, two vectors A and B are in XY Cartesian coordinate plane. So it's a two-dimensional vectors. A, okay, is 85 newtons, 90 degree. Okay, 85 newton at 90 degree, and then B is 130 newtons at 150 degree. So express the vector A and B in the X and Y component. Okay, in the X and Y component. So this is what we can do. First, we draw that two vectors, okay, on our Cartesian coordinate system. That is our X, and this is our Y. Okay, perpendicular to each other. Now our first vector is 90 degree. So let's call our vector, the first one, A, is a blue color. Okay, so we draw our first vector A. Now this A is at 90 degrees. So we know that our vector A, which is equal to 85 Newton, is 90 degree with the horizontal. Okay, why we know it's 90 degree like that, not here, not the other direction? Because when you refer to angle, your angle starts from the x-axis, positive x-axis. So it starts from here actually. From here, go anti-clockwise. Okay, 90. And now the second one is vector B. Vector B is 150 degrees. So from x-axis go to 150 degrees. We have a vector of 130 Newton. So it must be longer than this vector A. So slightly longer like that. Alright. Okay, there's our B. So vector B is equal to 130 Newton. Okay. And we know that this angle here is 150. Here, orange color. 150 degree. All right, so after that we can actually find their respective component. The easy one is A itself is a vertical component. Okay, the A itself is a vertical component, so we first look at for A. Okay, for A, our component here is it has 0 I component. Okay, a 0 I component, so we can write down our A exactly like that. 0 I component, but with itself 85 Newton, which is 85 J Newton. Okay, but since this one 0, so we no need to write it down. 85 Newton J. Okay, like that. All right, so that is our A in the form of component. Now next one is for B. Okay, for vector B. So for our vector B, our B now we have 2. Okay, the vector B, you have one horizontal component. Okay, another one is our vertical component. So I use red color for the component. Yeah, so this is our horizontal component for B. I'll call this one BX, and this one, the vertical component, I'll call this one the BY. Okay, so you use trigonometry to solve that part of the problem. So our horizontal component, okay, if you look at this one, this angle here, or you can actually use this one, because our horizontal component normally will refer to cosine function. So our bx, we can write down first, bxi plus byj. But our bx is the 130 cosine 150 degree. So this whole thing here belong to the bx. It is I. And then plus our by is the vertical component. So we have 130 sine 150. And this is j, all in Newton. Okay, with the help of calculator, you have 130 multiplied by cosine 150. Okay, you get negative. Automatically come out 113 I, and then plus 130 sine 150. So we have 65. Okay, 65 j Newton. So that is our answer for B in the form of component. Okay, so okay, next we have January 2018. Question number 3. We have defined scalar and quantity and vector quantities. Same thing. You can refer to question 1. Okay, you can refer to question 1, number 4 here. Now you are given two vector. All right, vector A 6 meter at 30 degree. Okay, we draw that vector first. Our first one is our first vector A. Okay, so we have A 30 degree. Okay, the vector A, which is 6 meter at 30 degree. Okay, in the xy plane. So we have to express that one in ij notation. So we know that this one we can resolve the vector into two components. Okay, so one is your ax, another one is your ay. So we start with the A is actually equal to axi plus ayj. Okay, our ax is 6 cosine 30, and this one is I, and then plus our 6 sine 30 degree for the j. Okay, then we have 6 cosine 30. Our answer is 5.2. Okay, 5.2 I plus sine 30. This one will be half only, 3.0 j in meter. All right, so that is our A. Okay, our vector A. Now next is our vector B. Your B is given 180 degree. So if this is your x coordinates, and this one is your y. Now this is your B. Your vector B is 10 meter. Okay, 10 meter. So this is our B equal to 10 meter at an angle like that. This one is 180 degree. Okay, so 180 degree is pointing to the left hand side. So the B itself is the horizontal component. So in that case, well, you can straight away write, okay, B is equal to negative 10 I meter, or if you really want to follow the protocol, okay, like that, you can do so. If this is the only question you can do out of all the questions, then you can spend your time doing all these things. Okay, Bx, okay, we know that this one using cosine, right? So we have Bx, which is equal to 10 cosine 180, okay, plus 10 sine 180, and j. Okay, cosine 180 give you negative 1. So you have negative 10 I plus sine 180, 0. So answer for the B is only negative 10 I meter. Okay, but you want to be fast, you know that that one pointing to the left is negative I. Okay, negative I. Alright, so this is our question 4. Next, question 5. Question 5 lists two examples of vector quantities. Well, close your eyes, you can mention 10, I believe. Okay, so two examples, force, and another one, momentum. Okay, force and momentum. Okay, 6. Given vector A, 25 meter, 58 degree below negative x-axis. Okay, we draw that first. Our A. Okay, our A. I'm going to use coloring here. Okay, so this is the x and the y axis. X and this is y. So our A is 58 degree below. So it is 25. So this is our A. So the A here is 25 meter and the angle here is 58 degree below negative x-axis. And our vector B is 32 meter above positive x-axis at an angle of 62. So that means slightly larger than this. Okay, so there's our B, longer also. So B is 32 meter and an angle of 62 degree. Okay, so that is our vector, okay, given by the questions. Now, A, express vector A in x and y. Okay, x and y. So A. Okay, now we can start doing that. But first, you have to know that the total angle is what? 58 plus 180. So our 58 plus 180 is 238 degree from here. Okay, all together from here. Yeah. So you can start your angle from x. 180 plus the 58. So you have 238. Okay, 238. So our A vector is equal to 25 meter cosine 238 degree I plus 25 sine 238 degree, and this one J, and it is in meter. So our cosine 25 cosine 238 give us negative, okay, 13.2 I, and that one will be, so this one should be negative, I think. So we have 25 sine 238. Okay, so negative as well, 21.2 J meter. Okay, that's our answer for component in IJ. Okay, but if you look at question 6b, compute the magnitude and direction of vector A minus B. So that means you have to find the component for B as well. So we calculate the component for B in section 6b here. So our vector B makes 62 degree. So that one will be 32 cosine 62 degree, and that one is I plus 32 sine 62 degree, and that one in J. Okay, we have 32 cosine 62, so answer is 15.0 I, and plus 32 sine 62, we have 28.3 J meter. That is our B. Okay, that is a B. Now the question want to find, compute the magnitude and direction of vector A minus B. So we do the subtraction of vector using the component A and a B. So we have this A minus B, simply this one minus this one, you're going to have 28.2 negative 28.2 I, and this one also the same. This one minus, you get negative. Okay, this one had to so we have minus 21.2 minus 28.3, so negative 49.5. Okay, J meter. All right, that is our answer for A minus B. Okay, now we need to draw this vector. Okay, we need to draw this vector. Yeah, so our vector will be both negative, so we plan ahead so that you don't waste time redrawing the that one again, the vector again. So this is our vector A minus B. Okay, that's our vector A minus B. So we have two components. Okay, why we draw the vector like that? Because you got two components which you already calculated. This one is your negative 28.2 I, and this vector here is your negative 49.5 J. See? So there are two things that you have to give me. So the first is the magnitude of this vector. How long is the angle? How long is the vector here, A minus B? And what happened here is to find this, because you know this is 90 degree here. So this one is a 90 degree triangle. So the magnitude of A minus B is simply Pythagoras theorem's calculation. So you have this negative 28.2 square plus negative 49.5 square. Okay, let's see what we have here. So we have 28.2 square plus 49.5 square. And don't forget the square root here. So answer is 57.0 meter. That is our magnitude. Okay. Now angle, we normally refer to horizontal axis. So we call this one theta. Okay, you can call it theta. So we can use tangent. So tangent theta is equal to this one. Okay. This one is 49. So 49.5 divided by 28.2. So your angle will be up tangent 49.5 divided by 28.2. Okay, answer is 60.3 degree. Okay, 60.3 degree. So that is our answer for question number 6. Okay, question number 6. All right. Okay, this is our page 1. Okay, we go to next question. Go to page 2 now. Page 2. Okay, question for June 2017. That is question 7. Okay, question 7. You are given 3 vector M, N, and O. Compute the magnitude and direction of vector L equal to M minus N plus 2O. Well, that is easy because it's already given in an IJK format. So we have M equal to 5I minus 7J. N is negative 5I minus 4J. O is 3I plus 2J. Okay, the question 1, L is equal to vector M minus N plus 2O. Okay, not 20. Okay, we just put in their components. 5I minus 7J minus negative 9I minus 4J. And finally, plus 2 vector O. Okay, we can open up that one and then combine the I and the J. I only and J with the J. Yeah? So we have 5I minus minus become 9I, and this one is plus 6I. Okay, we're done with I. Next one is a J. Negative 7J, and then minus minus or plus 4J, and last one is plus 4J again. So what is our answer? So we have 9 here. So you have this one is 15 plus 5, you have 20I. And last one, this one is 8 minus 7, so we have only 1J. No units, okay? So your answer is 20I plus J, 1J, okay? So next, question 8, okay? Question 8. So question 8 is September 2016. Okay, question 8. Now we have September 2016. Question 8 is a vector Q is 30 meter long and makes an angle of 70 degree counterclockwise from the positive y-axis. Okay, first draw that vector. So your vector, this is x and this is your y. And it says the question is 70 degree counterclockwise from positive, this one. So we have this vector here. So you can draw the vector using blue color. That one. That is your vector Q. So your Q here is 30 meter long with an angle here is 70. Okay, 70 degree. So 70 plus a 90 here, this one is going to be 160 degree. Okay, 160 degree. So sketch the XY component of Q in that X and Y axis. So we just simply resolve the vectors. So let's call this one QX, and this one will be our QY. Okay, QX and QY. Sorry, QX. This is QY. Okay, sketch ready. Next, compute the value X and Y component of Q. So we calculate component only. So value here. So Qx is equal to what? 30 meter multiplied by cosine, and the angle is 70 plus 90. We always calculate angle from here. Yeah? So this one is in x component already. So you can put the I if you want, but still in meter. Yeah? So now you have 30 cosine 160. Answer is negative 28, okay, 0.2 I meter. Okay, that is our Q value, Qx, sorry. Okay, and then Qy is equal to 30 sine, same, 70 degree plus 90 degree J meter. So we have 30 sine 160. Answer is 10.3 J meter. Okay, I don't have to put them together because the question only asks for the component, the value of the component. Okay, so that is our that is the question for September 2006. Okay, next one. Okay, next questions September 2015. Okay, so question is giving us a diagram like that. So 9, that is question 9. Figure above shows two vector A and B are in xy plane. Okay, so A express vector A and B in x and y components. B compute the magnitude and direction of vector A plus B. And this question is quite similar to question number 6. Okay, so we first we can no need to draw. So we have that component there. Our 9A. Okay, our 9A. So express A and B in xy component. So we start with A first. So A is this one. Okay, this is our A component, A vector here. You have at Newton at angle 70 degree here, 70 degrees. So you have at cosine 70, and this is I, plus at sine 70, and this is our J in Newton. Okay, so at cosine 70, you have 2.7 I, and plus the at sine 70, so you have 7.5. Okay, 7.5 J Newton. So that is our X, our A. Next one is the B component. So our B component is this one. So this one is 30 degree. So the angle from here measure is 180 plus 30, so you have 210. Okay, so this one will be 5 cosine 210, and this one is I plus 5 sine 210. It's J in also Newton. Yeah. Okay, our answer will be 5 cosine 210. So you have negative 4.3 I, and next one is 5 sine 210. So we have negative 2.5 J Newton. Alright, so there is our B component. Compute the magnitude and direction of A plus B. Okay, you already have them in the component format. So now we draw that vector. Okay, we draw that vector. We use this our coordinate system. This are x and this is y. So our component is like this. Your horizontal component is negative 4.3 I, and then your vertical component is this one, negative 2.5 J. Okay, so when you combine these two, you're going to get this vector. Okay, sorry, my mistake. I only draw B, so wrong. This one is wrong. Cancel. Okay, this is wrong. I'm supposed to sum them up first before I draw. When you are sick, your brain can't function properly. Okay, this is a shaded area. Okay, 50 shades of gray. Okay, all gone this one. So now we need to find what? Compute the magnitude and direction of A plus B first. Okay, we calculate A plus B here. Okay, do it here. A plus B, so component sum up. Okay, you sum up the component. I with the I, 2.7, so minus 4.3, you get negative 1.6 I. And finally, this one you plus, okay, you got positive 5.0 J Newton. Okay, that is our vector now. Okay, so we have a negative component X. Okay, and then later on you're going to have a positive, okay, positive Y. Okay, this is our Y component. So our horizontal component is negative 1.6 I, and the positive component is 5.0 J. So if you combine these two components, you're going to get A plus B. Okay, so this is our vector A plus B. And there are two things you have to calculate. Number one is the magnitude, Pythagoras theorem. Number two is the angle. So we call this one angle theta. Okay, so our magnitude, A plus B, the magnitude is, we can use the component here. Okay, we can use the component here. We will have a square root of negative 1.6 square plus 5.0 square. Okay, oh, plus, right? Okay, correct. So we have this 1.6 square plus 5 square, 25 square root everything, you have 5.2. Answer is 5.2 Newton as a magnitude. And direction, we use tangent. Tangent theta is equal to this 5.0 over negative 1.6. So your angle theta, up tangent, 5 divided by negative 1.6. So negative 1.6. So answer is negative 72.3 degree. Okay. Alright, now the question is, what's the meaning of that negative sign for the angle? Okay. So because our angle normally if you look at our right angle coordinate system, right? Our hand is moving from X, our finger here, X to Y. You curl your finger to Y, your thumb points up. So points out from a surface is a positive Z direction. So everything that point out, that thing must have some sort of rotational concept that is anti-clockwise. So anything that spin anti-clockwise is going to have a vector quantities pointing out. Okay, if they have, in physics normally they have, and that is called a positive value. If into it, it is negative. So now look at our angle. Our angle are measured from the horizontal axis, right? So our angle actually are measured horizontal, go to that vector A and B. Okay, A and B. So we flip our palm like that, so it spin anti-clockwise now. Your thumb point in, so the angle theta is negative. But actually, in this case, it doesn't matter it's positive or negative, because it's only the magnitude of the theta that we want. But if you do further analysis, deeper analysis, then only the negative sign is important. Okay, for your case, that is not important. Don't even have to explain that. So you can just simply put the answer as a positive value, or you drop that one. Okay, so this one, it can be something like this, 5 over 1.6, so that your answer is 72.3 degree. You get the same marks. Okay. All right, next. Okay, next one is March 2015. March 2015. That one is our question 10. Okay, our question 10. Now, question 10, given vector A, given vector A 3i plus 4j, and then the B is negative 6i plus 4j, and C is 9i minus 5j. Okay, so compute the magnitude and direction of vector D, A plus B plus C. So D is A plus B plus C. So just sum up all the component separately, I and I, J and J. This one 9 minus 6 got 3, 3 plus 3 is 6, so we have 6I, and this one is 8 minus 5, you got 3J. Okay, so now you can straight away calculate, or you can draw like that. Okay, but since you already have been through this one for so many times, you should be able to imagine what happened here. So first we calculate the magnitude, so that will be this 6 square plus 3 square, everything square root. So we have 36 plus 9, and then you square root them, you got 6.7. Okay, 6.7, and the unit is not given, so the magnitude is only 6.7 units. Put something like that, okay, so that you don't get confused. And then the angle, we assume that the angle, you imagine this one is pointing to your right, and then the I is pointing up. So the vector is somewhere in the first quadrant. So our angle is from the positive x direction. So we can use tangent theta. We assume the angle is theta. So it is 3 over 6. So this one will be half. Okay, half up tangent 0.5. Okay, your answer for theta is 26.6 degree. Okay, 26.6 degree. All right, so that is our March 2015. All right, okay, next. Okay, now is question 11. That one is September 2004. Question 11. Okay, the question asks two forces A and B act on a car. If force A is 120 Newton at 30 degrees north of west. Okay, so we draw that force on the x-axis, x and y-axis. Now you have to be very clear how to interpret that one into diagram. Yeah. Okay, now we know that our y-axis point to also the north. Okay, this one is the north, this one is the east, this one is the west, and this one is the south. Whoever don't know this, go back to your geography class. Okay, now first one is A. Okay, force A is 120 newtons. Okay, at 30 degree north to west. Okay, north to west. Okay, well, what's the meaning of north to west? It's actually not north to west. It should be north of west. Okay, we never mention it north to west. It should be a typo error there. So this word here change to north of west, so that we standardize our question and also answer. Yeah? North of the west, that means 30 degrees from the west. This is our west here. Okay, so I use orange color for our first force, and that one is 30 degree north side of your west. This is your north, this is your west. The north side of your west is that angle. Okay, so I draw this one. This one is 30 degree, and this is vector A. Okay, vector A, which is 120 Newton. So we read again. Yeah. So now we see if force A is 120 Newton at 30 degrees north of west, the northern part of your west, this is the northern part, this is the southern part. If the question change to south of west, then your vector will be here instead of up there. So you have to know how to interpret words into diagram. Okay, next one is B. Force B is 200 newtons at 60 degrees south of the west. This is south of the west, so this part here we don't use anymore, so it is here 60 degrees south of the west. This is very clear that two vectors actually pointing at 90 degrees from each other. This one is 200 Newton. Okay, so our B is 200 Newton at this angle 60 degree. Okay, south of the west, the southern part of your west. Okay, so now we have two vectors that looks 90 degrees from each other. Now calculate the magnitude of A plus B. Okay, the magnitude A plus B, magnitude only. So in this case, we will try another approach. We can actually use drawing method. Okay, you can use drawing method. So we want to sum up A with B. So since no direction is needed, right? So we actually draw the vector just simply using a normal diagram. Okay, this is our orange color, yeah. Okay, that is our A, and then you want to plus your B because question asks for A plus B, so we follow parallel that vector, and that one is your vector B. Okay, that is your vector B, and this is your starting point, initial, this is your end point. A plus B means from A go to B, and that is your vector A plus B. And since this one is 90 degree, because 30, 60, 90 degrees, so we can use Pythagoras theorem. Okay, so magnitude only will be this one square plus that one square, everything square root. So your A is 120 square plus 200 square. So we have 120 square plus 200 square, square root everything. We have 233. Okay, answer is 233 newtons. Okay, 233 newtons. All right, so that is our question number 11. Okay, next one. Next question, March 2014. Okay, March 2014, question 12. Okay, question 12 asks, state the difference between scalar and vector quantity and give two examples of each quantity. Okay, difference between scalar. Well, first we write what are similar. Both of them have magnitude. Okay, but vectors, okay, has direction. Okay, vector direction, scalar don't have. So example, for scalar, what are those examples? Mass, okay, and time. And then for vectors, okay, we have answered that one for vector before. We use something else now. Vector you can call velocity, and displacement we go to very basic. Okay, displacement. All right, so that is our answer for 12. Okay, for 12. All right, now come to the next one. All right, this is our page number 3. Yeah? Okay, next question 13. That one is still under March 2014. So question 13. Yeah. Now question 13, we follow the diagram given like that here. This is one. Two forces shown in figure above X on a body located at the origin. Okay, write the two forces in unit vector ij and compute the magnitude Q plus P. Well, Q plus P and P plus Q are the same, but we redraw the vector because one of the vector is pointing like that. So since vector is frame independent, so we can actually move the vector to this direction. So now we draw the coordinate axis first. Okay, Y. So now we have our first vector P first. We draw P at 40 degree. So here, this is our P, 30 Newton. At 40 degree. So be careful here, 40 here, and this is our 40 degree here. 40. Later we're going to use this angle here. And then the next vector, now I'm going to use red color. This one is Q at 35 degree. Okay, but only 20 Newton, so slightly shorter. So our Q is 20 Newton, and this one is 35 degree. Okay, so now we can find their ij component. So first one, P. Our P, we have 30. Our component here, horizontal component is P, 30 cosine. Now, what's the angle here? This angle here is 270 minus 40. So we have 270 minus 40 to show you so that you know what happened next when you do division here. Next, 30 sine, that one also the same, 270 minus 40 J Newton. Okay, so that will be 30, and then we have cosine 270 minus that one is 230. Answer is negative 19.3 I Newton. And this one, next one is 30 sine 230 also, so have minus also. This one we don't write a unit in the between, minus 23.0 J Newton. Alright, so that is our P. And next one is our Q. So our Q will be this one. So the angle here is 180 minus 35. So we have 20 cosine 180 minus 35 degree I plus 20 sine 180 minus 35 degree J Newton. Okay, our first answer is 20 cosine. This one 180 minus 35. Okay, we have minus 16.4 I. Next one is 20 sine. This one 180 minus 35. So we have positive 11.5 J Newton. Alright, so that is our X vector Q. And then compute the magnitudes, okay, of Q plus P. So our Q plus P, you just sum them up. So now when we sum them up, we have this one, 19.3, okay, 19.3 plus 16.4, both negative here, so minus 35.7 I, and then this one here, so 11.5 minus 23, we have minus 11.5. This one is J Newton. Okay, our magnitude of Q plus P is the square root and the square, the sum of the square here. So we have 35.7 square plus negative 11.5 square, and let's find out what's the answer here. 35.7 square plus 11.5 square, and don't forget to square root 37.5. Okay, Newton. Alright, direction is not asked, so no need to find the direction. Okay, our answer is 37.5. Alright, next. Okay, come to question number 14. That one is September 2013. Okay, September 2013. Question 14. Given two vector, A is 3i plus 6j and B is negative 4.5i plus 3j. So A, determine the magnitude and direction of the vector A and B. Well, that one is you can draw if you want. So I think we just draw it first. We draw both the vector. Okay, we do it here. Yeah? So our vector A, both positive, X, Y, and another one is for the B. B have one negative, so we put it here. Okay, this is our vector A, 3, and like that. So our vector A here, we have two component here. This is the 3i, and then you have one more here. This one is the 6j. So when you combine both of these 9, you get this vector. Okay, that is your A. This is your vector A, and let's assume angle here is alpha. Okay, alpha. Next, the second vector will be B. Okay, the second vector will be B, which is negative 4.5 and 3. Negative 4.5 is pointing to your left, right? Negative 4.5i, and 3j, positive 3j is here. So now combine these two, you're going to get the next vector B. Okay, that one. This is vector B with an angle here. Maybe you can call this one beta. Okay, beta. Alpha A, beta B. Easier that way, don't get confused. Okay, so next one, we can calculate the magnitude. Magnitude is easy. Magnitude of A is equal to the square root of 3 square plus 6 square. So we have square root of 9 plus 36. Okay, answer is 6.71. No unit, just simply put units. Okay, B. Square root of 4.5 square plus 3 square. So 4.5 square plus 9 square root. Our answer is 5.41 units. Okay, units. Alright, so that's the magnitude and their direction. Okay, direction. So direction we calculate our tangent alpha. Our tangent alpha for this one is 6 divided by 3. So it's 6 over 3, which is 2. So alpha will give you 2 here. So we have 63.4 degree. Alright, so that is our A. Then next one is tangent beta here is 3 over 4.5. We only take the positive here. So our beta is up tangent again. This one is 3 divided by 4.5. So we got 33.7 degree. Okay, so that is a part A. Next, B. B asks for determine the magnitude and directions of A plus B. So our A plus B is equal to that 2 sum up. Okay, that 2 sum up, what do you get? 3 minus 4.5, you got negative, okay, negative 1.5i plus this 2, okay, 9, okay, 9j. That is our vector A plus B. So magnitude is equal to the square root negative 1.5 square plus 9 square. So we have 1.5 square plus 81, that one, and then square root everything, 9.1 units. Okay, now another one is direction. Okay, direction. So our direction, we draw that component like that. X, so that is our component. First one is negative 1.5, very small, negative 1.5i. Another one is the 9j. Sorry, okay, combine the two vector, you get this. Okay, that is your A plus B. Okay, the angle here we put as theta. Okay, so our magnitude already done. We use tangent theta is equal to 9 over 1.5. So our theta will be up tangent 9 divided by 1.5. We have 80.5 degree. Okay, 80.5 degree. So that is our section B. Now the next part will be this is our page 4. Now the next part here, the last part is 14C here. C asks for if A plus B plus C. Okay, if vector A plus B plus C is equal to 0, so find the magnitude and direction of C. Well, you want to find C is equal to negative A minus B. Okay, so if we put the component in, we already have you already given a component like that, so you use you can actually take out the negative sign here. So now we have A plus B, easier that way. And our A plus B, we already calculated that value. A plus B is equal to this, minus 1.5i plus 9j. Okay, minus 1.5i plus 9j. So we have minus 1.5i plus 9j. So now the negative sign go in, it become 1.5i minus j, minus 9j. Minus 9j. Everything is the opposite now. Okay, so question 1 to find magnitude. Okay, magnitude of the C must equal to the same magnitude. So your magnitude of C must equal to the magnitude of your A plus B. Okay, A plus B. So your value is, we already have that value actually, 9.1. Okay, 9.1. So we have 9.1 units. And then the angle, the direction of your vector C here is the opposite compared to your A plus B. Okay, so we can draw that vector, no problem. We have positive and negative I. So these are X and that is our Y. So our vector C is this one. Positive 1.5I and negative 9j, and when you combine these two vectors, you get the vector which is opposite to A plus B. Okay, so see, this one pointing like that and this one pointing the other direction, and this is a theta. Now if you calculate the tangent theta, you're going to get the same thing here, 9 over 1.5. so angle should be also the same, 80.5. okay, 80.5 degree. Magnitude the same. The only thing different is if you refer to the diagram, is totally opposite direction. Magnitude the same. Okay, so that is our question number 14C. Next one, March 2013. Okay, March 2013. Okay, question 15 here. So given a force P, 20 Newton is directed at angle 60 degree above the positive X, and a force Q, 30 degree directed at angle of 60 degree below the positive X. So determine the magnitude and direction of 2Q minus P. Alright, draw the vector first. Okay, that one will be 60 degree. So we need a larger space for that. X and Y. So we have two vectors there. The first one is 20 Newton, 60 degree above. Okay, that is our P. 20 Newton at 60 degree above. Another one is slightly longer, like that. And that one is a Q, 30 Newton. And angle also the same. Okay. Okay, next. Determines the magnitude and direction of 2Q minus P. So 2Q minus P. Okay, so 2Q minus P. So before that, you have to calculate the component. So before this, we find component P. Okay, for P is equal to 20 cosine 60. That is the I, and then plus 20 sine 60j, and that one in Newton. So our cosine 60, that one is half, right? So 20 cosine 60, 10 I, plus we have 20 sine 60, that one is 17.3 j Newton. Okay, that's our P. Next is our Q. Q, slightly different angle here. From here, horizontal axis X positive go around to that vector, that is 360 minus 60, so 300 degree. Okay, so we have 30 cosine 300 degree I plus 30 sine 300 degree j Newton. Okay, 30 cosine 300, answer is 15. Okay, 15 I plus 30 sine 300, that one will be negative already, so we have negative 26.0 j Newton. Okay, so next one, we calculate the 2Q minus P. Okay, our 2Q minus P will be 2 of this, so 2 times 15I minus 26J minus 10I plus 17.3J. Okay, so now we have 30. Okay, 30I plus 32J minus 10I minus 17.3J. So end up with I with I, you have 20I, and this one become you sum up the two number, you have 49.3J. that is our 2q minus p in ij unit vector. Okay, so the next one is to calculate the magnitude. Well, magnitude is not a problem here, magnitude. So we can draw that vector first. Okay, we can draw positive and negative. So we have this vector. These are x, these are y, and these are vector. The net value is 20 first, 20i, and then negative 49.3. Negative 49.3j. So we combine these two vectors, we get this vector. Okay, this vector here is 2q minus p. So angle here, so we call this one theta. Okay, we call that theta. So now we can calculate the magnitude. 2q minus p, magnitude is square root that one square plus negative 49.3 square. Oh, sorry, square outside. So that's our answer. 20 square plus 49.3 square and square root. You have 53.2 Newton. Okay, 53.2 Newton, and then we calculate the theta. Tangent theta is equal to 49.3 over 20. So our theta will be arctangent 49.3 divided by 20. Answer is 67.9 degree. Okay, so that is our answer for 2q minus p. Right, done. Okay, next we go to questions October. Okay, October 2012. Okay, question October 2012. Okay, need to sharpen my pencil. Okay, October 2012. Okay, we are given three vectors. For the vector given above, okay, determine the magnitude and direction of 3a minus 2b plus c. You can use drawing method, but this one is complicated. If you draw, it might not have the accuracy that we want. Okay, our first one. We split the vector into ij component. Okay, this is our page 5. Okay, our ij component here, that component will be a first. So a is 55, and then we have cosine 22 degree, I plus another one 55, sine 22 degree, j. They are all in meter. Okay, we can put that value there first. We come back to calculating the value later on after we write down all these components. We have this 34.5 cosine. The angle from the x-axis should be 180 minus 52. This is I, and then plus 34.5 sine, and same angle here. There's a j in meter. Then c. C is 38. Well, 38 is easy, that one. Okay, 38 we straight away give the answer as negative 38 j meter. Okay, C immediately got the answer. The rest we need calculator. Okay, this one is 55 cosine 22. 50 or 51.0. Okay, I, and then 55 sine 22. So I have 20.6 plus 20.6 j meter, and there's our answer for A component. B, 34.5 cosine 180 minus 52. Okay, answer is negative 21.2 I, and the next one is 34.5 sine 180 minus 52. Okay, we have 27.5 positive, 27.2 J meter. Okay, done already for A, B, C in the component. Next, we just need to calculate, okay, 3A plus, minus 2B. Minus 2B and plus C. So we can straight away sum up their I value. I here. So 51 minus 21.2 minus 38, and we get negative 8.2 I. And the J now, 20.6 plus 27.2. That's it. Okay, so we have 47.8 J meter. That is our result for 3A minus 2B plus C. Next, we're going to find the magnitude and direction. So we draw that vector. Okay, we draw that vector. So I straight away draw without using the x and y axis here. So this is my vector negative 8.2 I, and this is my vector for, oh sorry, mistake again. Positive supposed to go up. Okay, positive supposed to go up. Okay, I use other color, blue color. Okay, blue color. So my negative is here. That one is negative 8.2 I, and this is 47, okay, 0.8 J. So now you combine that two horizontal and vertical component, you get this vector, and this vector here is your 3A minus 2B plus C, the pencil one. And you need to give a angle also. We call this theta. Now magnitude of 3A minus 2B plus C is simply the square root of the component square. So we have negative 8.2 square plus 47.8 square. Our answer will be 8.2 square plus 47.8 square, and square root, get 48.5 meter. Okay, 48.5 meter. And then tangent theta is 47.8 over 8.2. So our theta will be arctangent 47.8 divided by 8.2. Okay, at t.3 degree. Okay, so that's our answer for question 16. Okay, next, okay, next question 17. That one will be from March 2012. Also giving us a diagram, vector A, B, C. Three coplanar forces. Coplanar means they are on the same surface, two-dimensional. Shown in figure above. Find the magnitude and direction of the resultant force for these three coplanar forces. So we just need to find the their value or the vector in respective component. Okay, we start with A first. A is 4 Newton cosine 30, that will be I, plus 4 sine 30 in J. They are in Newton. Okay, we'll come back to calculate later. B is 10 Newton cosine, angle already given, 135 degree I, and plus 10 sine 135 degree J Newton. And the C, next one is 4 Newton cosine, this one is 60 plus another 180, 240. Okay, 180, 240 degree I plus 4 sine 240 J Newton. Okay, so our answer here will be 4 cosine 30. That one is 3.5 I, and this one is half, 2.0 J Newton. Okay, our first one. Then the next one, this one is 10 cosine 135. So I have negative 7.1. Okay, 7.1. I plus 10 sine 135. So I have 7.0. Again 7.1. Okay. J Newton. Alright. Next one, 4 cosine 240. That one will be negative 2.0 I, and 4 sine 240 negative 3.5 J Newton. Okay. Now we have to sum up because the question asks for resultant force. So we sum them up. Okay. So we call that resultant force F. So that will be A plus B plus C. So we simply sum up all the I components first. Sorry. So our I component will be 3.5 minus 7.1 minus 2. So we have minus 5.6 I. And this one, 2 plus 7.1 minus 3.5. So answer is positive 5.6 J Newton. That is our resultant force. But the question 1, magnitude and direction of resultant force for these 3 coplanar forces. Okay, so we draw. Okay, we draw. Draw is better, I think. So we have this. So I'll draw this force first. Okay, this is negative 5.6 I, and then this one is the same length, 5.6 J. So when you combine both of them, okay, you get the vector that is exactly 45 degree. Alright, so that is our F. So this angle theta, okay, we can calculate later. Okay, magnitude is the square root of negative 5.6 square plus 5.6 square. So our answer is 5.6 square plus 5.6 square and square root 7.9. Okay, 7.9 Newton. And the angle, no need to calculate because they're the same. Your theta must be 45 degree. Okay, so that is our answer for question March 2012. Okay, next one. Next one is question number 18. So this one is 17 just now. Okay, now 18 is September 2011. Okay, 18. Now, state 2 major differences between scalar and vector quantity and give example for each. Okay, this one I want you to refer to question 12. Okay, refer question 12. Alright, next we go to 19. Vector A has a magnitude of 8 units and made angles of 50 with a positive x, and B 10 units and directed along the negative y direction. Okay, draw that vector. Y, x. So our vector A is at and 50 degree above here. This one is 50 degree and vector A is at 0.0 units. And the next vector is directed along the negative y, and that is 10 units. Okay, 10 units, and that is our B. Okay, 10 units. Okay, 10 units. Okay, so A, resolve. Okay, resolve each vector into the x and y. Okay, we do A first. Our A is equal to at cosine 50 I plus at sine 50 J. So I have at cosine 50, it is 5.1 I, and at sine 50 we have 6.1 plus 6.1 J, and that is our ij component for A. And B is easy because B is pointing downward. That is exactly negative 10 J. Okay, negative 10j. Alright, so that is a component, the A part. Now the B, determine the magnitude direction of resultant force, resultant vector C A plus B. So simply sum them up. Okay, so you have 5.1 minus 10, 4.9, negative. Okay, negative 4.9 I, and that's, oh sorry, that is J. Okay, so that means you only have one I, so that one is 5.1 I, and this one is 3.9 minus 10. Okay, negative 3.9 J. That is our resultant, but calculate the magnitude first. You can use it. The magnitude C is equal to the square root of 5.1 square plus negative 3.9 square. Okay, 5.1 square plus 3.9 square, and square root, you got 6.4. 6.4 units, and tangent theta is equal to always the y component divided by the x component, yeah, 5.1. So theta is up tangent 3.9 divided by 5.1. So you have 50. Up tangent 3.9 divided by 5.1. 37. Okay, 37.4 degrees. Okay, so there's an answer for our questions 19. Okay, 19 done. Next, page 6 now. Okay, April 2011. April 2011, question 20. So two vector A and B lie in the XY plane as shown in figure above. So given A, 20 cm 15 degrees from vertical, and this one is 30 degrees from horizontal, 10 cm. Find the XY component for each component, each vector A. Okay, we start with what happened here? This is A, this is B, this is C. Okay, so our A, the XY component, we do straight here. That one will be 20 cm here. So you give your answer in cm, don't follow the other units. 20 cm, and you have cosine. There's a horizontal component. 90 plus 15, you have 105. There's a x component, and then plus your horizontal component. This horizontal, this one is a vertical, sine 105 j in cm. Okay, and then B, same thing. You have 10 cosine 30 I plus 10 sine 30 j in centimeter. So we have 20 cosine 105 negative 5.18 I plus you have 20 sine 105, you have 19.3 j in centimeter. Next, 10 cosine 30 at 0.66 I, and 10 sine, this is 5.00 j centimeter. Okay, the magnitude on the resultant vector, well, resultant is A plus B. So I have A plus B, sum up their component. You have 8.66 minus 5.18, so you have 3.48. 3.48 I, and these two sum up, you got positive 24.3 j centimeter. Okay, so the magnitude will be the square root of 3.48 square plus 24.3 square. So we have 3.48 square plus 24.3 square, and don't forget the square root, 24.5 centimeter. that is our B. Next, C, the direction of the resultant vector. Direction of the resultant vector, we draw this vector, or you can draw that vector like this. This is our 3.48i, and this one is our 24.3j. Okay, so that is our vector, resultant vector A plus B. So I'll call this one theta. So using tangent. Okay, so tangent theta is equal to 24.3 divided by 3.48. So arctangent 24.3 divided by 3.48. Answer is 81.9 degree. Okay, so that is the answer for the question 20. Right. Next. Next one is October 2010. Okay, October 2010, question 21. Vector A has a magnitude 100 cm and a direction of 46 degree, and vector B has a magnitude of 40 cm and direction 120. Everything refer to positive x direction. Yeah? Both angles are measured counterclockwise from the positive x-axis. Calculate the magnitude and direction of vector A plus B. Okay, so now without drawing, try to imagine that. Okay, so now I'm going to do without drawing. My vector A, okay, is equal to 100 centimeter. Okay, and this one is cosine first, our horizontal component. So cosine 46 degree I and 100 centimeter sine 46 degree J. Everything in centimeter. Okay, so I have to imagine that. Yeah. And then B is 40 cm. Cosine now is 120 degree I and 40 sine 120 degree J. Everything in centimeter. Okay, first one, 100 cosine 46 degree. You have 69.5. 69.5 I, and next one is 100 sine 46, 71.9 J centimeter. Alright, so there is our A in IJ format. And the next one is 40 cosine 120. That is negative 20. Okay, negative 20 I and plus 40 sine 60, 34.6 J centimeter. Okay, centimeter. And then find the resultant force. Your R is equal to A plus B. So the answer will be, well, that too. So sum up, you minus will become 49.5 I, and this one you minus 71.9 minus 34.6, you get 37.3 plus 37.3 J in centimeter. Okay, so there is a vector, but we need to find the magnitude first. Is equal to square root 49.5 square, 37.3 square, 49.5 square plus 37.3 square, square root. So we have 61 or 62.0 centimeter. And the angle, tangent, arctangent is 37.3 divided by 49.5. So the answer will be arctangent 37.3 divided by 49.5. You get 37.0. This one here is measured from the positive x-axis. Okay, positive x-axis. Yeah. Okay, next. Question 22. That one will be April. Okay, that one will be April. 2010. Question 22. Okay, we have vector A has a magnitude 3 units and an angle minus 30. Be careful, it's a minus 30. From positive x, minus 30 means below the x-axis. And then vector B has a magnitude of 4 and an angle of minus with a positive x. Go the other way around. Minus means you go clockwise. What is the magnitude and direction of vector sum AB? So both the vector are below the x-axis here. Why? So our vector A is 90 degree. This is our vector A. Okay. You go down minus 90. Go in this direction. Okay. 90 degree. Okay. Minus mean clockwise, because you turn like that, your thumb point into the paper. So that one will be vector A equal to 3 units. Okay, 3 units. Now vector B is 4 units but 120 degree here. That is a B, and this one here is 120 degree. Okay, and now that is 120 here up to here, 120 negative also. So B is 4 units. But when we do calculation using cosine and sine function, our angle are calculated from x. Positive go anti-clockwise. Okay, so our question is, what is the magnitude direction? Well, you can use, because 2 vector only, you can use drawing method if you want, but that one is a drawing, not accurate. So we go by component method. A itself is a j component. Okay, negative 3j units, and then our B we have to calculate because it meant an angle rather than vertical or horizontal. So we have 4 cosine. Now what is this angle? 360 minus, okay, 360 minus 120, you have 240. Okay, 240. So cosine 240i plus 4 sine 240j. Okay, so we have here 4 cosine 240, our answer negative 2. Negative 2i, and 4 sine 240 should be negative also, negative 3.5. 3.5j. Okay, our resultant or vector sum A plus B, negative 2i, and these two sum up become negative 6.5j. Okay, first magnitude, square root of negative 2 square plus negative 6.5 square. So we have 2 square plus 6.5 square, square root, we have 6.8 units. Okay, 6.8 units. And then angle, tangent, theta. Okay, angle. Now if you want to draw also can, okay, so that you understand more actually what direction is a vector. So both are negative components, see, so it's this and this. So component for the A and B is negative 2i and negative 6.5. Okay, negative 6.5j. So we lump them together, we get this vector, that A plus B. So the angle is here, so we call this one alpha maybe. So we have tangent alpha is equal to 6.5 divided by 2. So alpha will be arctangent 6.5 divided by 2, 72.9 degree. Okay, 72.9 degree. All right, so that is question number 22. Next, next question is 23. That one comes from October 2009. Okay, October 2009. Now 23, Vector A has a magnitude 35 meter and an angle 15 below the positive x, and vector B, okay, and vector B has 53 meter above, okay, one is below, one is above, so find the magnitude, blah 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 blah. Okay, vector A 35 meter, 15 degree below, so it's quite a short, quite a small angle, 15 degrees, and then we draw a bit slightly larger. Okay, there is our vector A, 35 meter, and the angle here is 15 degree only, and then vector B is above the positive x, 48 degree, but 53 meter, okay, 53 meter, that is B, 53 meter, and an angle of 48 degree, okay. So calculate, find the magnitude and direction of resultant vector A plus B, alright. So first we split them into components. A, vector A is 35. Now the angle of this vector from the positive x direction go counterclockwise is 360 minus 15, so it's 340. So we have cosine 345, that is I, and then 35 sine 345 j, everything in meter. Okay, we have 35 cosine 345, 33.8 I, and then this one is 35 sine 345. Answer is negative 9.1, or okay, negative 9.06 J in meter. So there is our A. Now B. B will be 48 degree from positive x direction, positive x axis, 53 cosine 48 I plus 53 sine 48 j in meter. 53 cosine 48, we have 35.5 I plus 53 sine 48, that one is 39.4 j meter. Okay, so that one is our A and B in vector component. Now sum up. R is equal to A plus B, so we have that two component, 33.8 I plus 35.5 I, so we have 69.3 I, and this one 39.4 minus 9.06, so we have 30.3 plus 30.3 J meter. That is our that one component. Now we draw that two vectors, and then after that we calculate magnitude and so on. So we have this 69.3 I and this one 30.3 J, and we combine these two to get our component, to get our resultant vector R. Okay, there's a R vector, and angle we call theta. Normally our angle refer to horizontal axis, yeah. So we have magnitude R is equal to the square root of 69.3 square plus 30.3 square. We have 69.3 square plus 30.3 square. Square root, we have 75.6 meter. And then the angle tangent theta is 30.3 divided by 69.3. So angle up tangent 30.3 divided by 69.3, 23.6 degree. Okay, so that's our answer. We have repeated this type of question for so many times. Okay, next question. April 2009. Okay, April 2009. That's question 24. Okay, you're given two vector. A is 5i plus 8j, and B is 9I minus 3J. Okay, A, draw vector C equal to A minus B. So we minus them first. So A minus B, 5 minus 9, you got negative 4I, add minus negative 3 becomes summation, 11J. So how do you draw this vector? Well, the C vector is negative 4I and 11J. So negative 4 will be pointing to your left, positive J pointing upward. So use red color here. This is our negative 4I. And this one is our positive 11J. So when you combine these two, this is a vector C. Okay, this is a vector C. Yeah. Here, right? So there is our vector C. Yeah, negative 4I plus 11J. All right, and then find the magnitude direction of vector C. Magnitude, angle is theta, so magnitude C is that one, negative 4 square plus 11 square, and the tangent theta is equal 11 over 4. So we have 4 square plus 11 square, and then square root everything, you got 11.7. Okay, 11.7 units. And then the angle will be arctangent 11 divided by 4. So we have 70 degree. Okay, 70 degree. So that is our question 24. Easy peasy. Next, October 2008. Okay, October 2008. 25. That is question 25. Okay. Vector A is 3 meter and 60 degree. Vector B 5 meter, negative 150 degree. Determine the magnitude direction for vector C, which is equal to C plus A. Okay, so we draw the vector first. Yeah. So we have one is 150 and another one is 60 degree. So we have a diagram that looks like this. Right. So our vector A is 3 meter. About 60 degree here. There's our A, 3 meter, but here is 60 degree. And then our B is 150 degree, 150 degree here. Anti-clockwise, negative, clockwise. Okay, so here is 150 degree. Okay, so that is our B, which is 5 meter long. So we need to find the A plus B. There's a C, but before that we have to calculate component. So component A is 3 cosine 60 I and 3 sine 60 J in meter. So this one is 1.5 I plus 3 sine 60. That one will be 2.60. 2.6 J meter. That's our A. B will be the same thing, except the B angle from positive X direction go counterclockwise, 360 minus 150. So I have 210. Okay, 210. That will be 5 cosine 210 I plus 5 sine 210 J in meter. Okay. So 5 cosine 210 give us negative 4.3 I, and 5 sine 210 give us also negative 2.5 J in meter. Okay, so there is our A and B separately in the IJ format. Now our C is A plus B. So we just sum up the vector. We have 1.5. You want A plus B, right? So minus 4.3. So you get negative 2.8 I. And the next one is this one sum up. You got 0.1 J in meter. Okay. So you can draw that vector, negative, positive. Okay, so there's our vector in component format, the resultant negative 2.8i and positive 0.1j. The angle must be extremely small. Okay, so that is the C vector, which is a plus b. So calculate our magnitude and also angle alpha, we call it. So our magnitude of C is a square root of 2.8 negative square plus 0.1 square. And then answer will be 2.8 square plus 0.1 square, square root. So 2.80, okay, 2.80 units, sorry, in meter. And then tangent alpha is 0.1 over 2.8, so the alpha will be tangent 0.1 divided by 2.8. Answer is 2.0 degree. Okay, magnitude and direction. Okay, magnitude and direction. Okay, now last one. October 2007. Okay, question 26. Vector A is 5 unit, okay, and B 5. Determine the magnitude and direction for vector C A plus B. Well, this question, just to let you know, is extremely easy because it's more or less the same. I can tell it's exactly the same as question 25, except that value is for A is 5 meters. So refer to question 25. You can do it, no problem. Okay, so that's it for our solution for tutorial 2. Okay, so make sure that you watch through this video so that you know how to solve vector problem from easy to difficult. Yeah. Okay, after that I'm going to snapshot, or I'm going to take photo of this and then upload to your WhatsApp group. Yeah, this apply to physics 145 for group